Hello, and this is your lesson for water. Now, our goals and objectives are properties of water that are critical to life, describe water as a solvent, water's cohesive and adhesive properties, acid, bases, buffers, and homeostasis, explain the pH table, and be able to make a molar solution. Now, why study water? Well, you're about 75% water, and so is the earth. It's about 75% water. Also, we have to have it to live. That's a very good reason to study it. All right, so water is the compound that supports all of life. It makes life possible on earth. So organisms are made and live dominated by water. Water exists in a solid, liquid, and a gas, and water has a rare property in a solid state as it floats on its liquid state. That is strange, isn't it? All right, so hydrogen bonds and water. Now, we talked about hydrogen bonds in chemistry on the last class. Water molecules are polar. Now, that's going to become important throughout the semester, whether something is polar or nonpolar. And water forms hydrogen bonds with each other. Hydrogen bonds last a few trillionths of a second. So they come apart, go together, a few trillionths of a second. I can't even fathom that. So let's talk about what makes something polar. Well, polar or nonpolar depends on bond type and shape. So if it's bent, has unpaired electrons, it's probably polar. If it is linear, like this, then it's probably nonpolar. Now you don't see any unpaired electrons there. But an easy way to remember if something is polar to me, I just say, will it dissolve in water? And if it will, it's going to be polar. So water's polar, and whatever dissolves in water will wind up, if it can be dissolved, polar. So likes dissolves likes. Now, nonpolar would not dissolve in water, like alcohol, like fuel, any kind of fuel, gasoline, propane, and fats. So they are nonpolar. All right, now properties of water. There are 4 main properties of water, and I'm going to go past this one right here because this is kind of still of our goals and objectives. All right, the first property of water is cohesion, and cohesion means that water sticks to itself. Water loves itself more than anything else, so it sticks to itself. And that enables that water strider to walk across the top because water sticks to itself. And it creates a surface tension, and it's kind of like stretching plastic over the water. And that's what makes that insect be able to walk on water. Also, have you ever filled up a tea glass and you can see that the water is above the glass and it doesn't fall over? That is also from surface tension. Now, under the umbrella of cohesion, you have adhesion, where water likes to stick to other things. You have capillary action, which is basically the thinner the tube, the higher the water will travel. So have you ever gone to the doctor and they pricked your finger to take just a little bit of blood, and they'll put a glass tube there, and that your blood just shoots up in there? That is because of capillary action. So the thinner the tube, the higher the water level. And that also helps enable water to get from the root hairs of a plant up to the top of the tree. Now, when we are talking about a plant, a lot of times we will call that turgor pressure, all right? But it works the same. Turgor pressure with a plant, and then capillary action, they all kind of work together to get that water from the root hairs up to the top of the tree. All right, number 2, moderation of temperature. So the first one, cohesion. Number 2, moderation of temperature. So without the water to absorb the heat in the summer and let it out, the heat out in the winter, the earth would be really cold. Now, water has a high specific heat or high heat capacity. So the water doesn't want to change temperature very much, and that's good because We are 75% water approximately, and therefore it helps us to hold on to our temperature better. All right, evaporative cooling, water will evaporate, and so if you're boiling water, it evaporates. If you sweat, the water evaporates, and that cools you. So it does the same thing for the earth. All right, so number 3 properties of water, insulation of bodies of water by floating ice. So water is less dense when it is frozen in a solid state because those hydrogen bonds become stable. Remember, the water comes apart a few trillionths of a second? Well, once it freezes, the hydrogen bonds are stable, and now the water will float on itself. Water is one of the few things that when it gets cold, it expands. Most things when they get hot expand and contract when they get cold, but water does just the opposite. Number 4, water is the solvent of life. Most things will dissolve in water. We already talked about some things that don't, but when you make a solution, you have a solute and a solvent. Water is the universal solvent. So if you dissolve a solute into the solvent like sugar or salt, solute plus solvent make a solution. Now, there's 2 different kinds of solutions. There's a hydrophilic, loves water. Hydrophobic doesn't love water. Fats, oils, fuels, waxes don't like water. All right, now a mole. A mole is 1 unit of a compound or molecule. So, for instance, let's see, O2. There's 2 oxygens in there. That's what you breathe, but that is 1 mole. Now, if I had that, that's not 1 mole any longer. There would be 2 moles there. H2O. Hey, go back. H2O, 1 mole. So a mole is just 1 of any substance. And so the number of molecules in a mole of 1 mole is 6.02 times 10 to the 23rd. That's Avogadro's number. 6.02 times 10 to the 23rd. So if you see a question that asks you how many atoms or molecules are in 1 mole of a substance, the answer is always 6.02 times 10 to the 23rd. All right, now molarity, the concentration of a material in a solution. So the number of moles of solute per liter of solution. Now, if you were going to make a molar solution, which we'll talk about in just a minute, but here's an example of that question. How many molecules of glucose with a particular mass of 180 daltons would be present in 1 mole? The answer, 6.02 times 10 to the 23rd. So if you were asked to find the molecular weight, that would not be the answer. But if you see the word molecular atoms, then that is the answer. All right, now, let's change this. Let's make this a little bit simpler. So how would you make a 1 molar solution of sodium chloride? Now, this is a half a mole, but standard generally is 1 mole. 1 mole, and it's written like that. So the first thing you would need to do is find the molecular weight of sodium and chloride. Now, we give that to you right here, but if you didn't know, you would get your periodic table. Remember, don't round on the weight. Once you get all of it totaled, then you can round. So it says 1 mole, I've changed it to 1 mole, of sodium chloride. So sodium is 23. Now if there was a 2 here, that means there would be 2 sodium chlorides, and I would have to multiply that by 2. But I don't, so there's only 1 mole of 23 daltons, and I'm going to change that to grams because remember they're equal. And let me change that. Okay, so it says sodium is 23 grams, and I only have 1 mole of sodium because I don't see a number there, and I only have 1 of chlorine as well. So chlorine is 35.5 grams. All right, so 5.5, 58 grams of salt, table salt, sodium chloride. So what I would do is I would get a flask. You always use a flask. And I would pour half the water needed into the flask. That says flash. And what is the standard amount is always 1 liter unless you're told otherwise. And 1 liter equals 1,000 milliliters. Nope. Okay, so I'm going to take my flask and I'm going to add half the water. So I'm going to add about 500 ml H2O. And then I'm going to pour my 58.5 grams into the flask, and then I'm going to fill it to the 1 liter fill line. That's how you make a molar solution of anything. You find the molecular weight, you need your periodic table, add half the water, add your substance, and then fill to the 1 liter fill line. So if I was asked to make a 0.5 molar solution, that has to do with the concentration. So I would only add half of that 58.5. But I'm not going to ask you, I'm just going to ask you a standard question about it. Okay, so we will go on. Now, we go past that. Water can disassociate. So when water comes apart, it can disassociate into hydrogens and hydroxides. Okay? And if it is an acid, there are more hydrogens in that solution. If it is a base, there are less hydrogens or more hydroxides. And then, of course, less hydroxides here. So you could look at either one. Now, water is neutral. H2O is neutral at 10 to the 14. All right? But if you have more hydrogens in a solution, it's an acid. More hydroxides in a solution, it is a base. All right, now how do you know if something's an acid or a base? If it is an acid, it's going to have a hydrogen in front of it. If it is a base, it'll have OH, hydroxide, on the other side. Okay, base, acid. All right, now the pH scale. So I don't know if you've ever taken care of a swimming pool or a hot tub or a fish tank. If you have, then the pH scale is very important. Now you can buy little pieces of paper and you dip it into the water and it will tell you by the color change whether it is an acid or a base. So what I want to convey to you is that, so a lot of times you'll see the pH scale. pH stands for potential of hydrogen. But the pH scale goes from 0 to 14, and in the middle is 7. 7 is neutral. 14 going to the right is a base. Going to the left is an acid. So lower is acidic. And I always think of LA, like Los Angeles, lower is more acidic. Lower than 7 is acidic. Okay, so you see each number here, 1, 2, 3. So if I ask you what is the difference between an acid, digestive juices of 2 and tomato juice of 4, you might say, very frustrating there, you might say 2. But each space is times 10. So between 2 and 4, so between 2 and 3 it's 10, and 3 and 4 is 10. So I'm going to put my 1 down, and I add my zeros. So 4 is 100 times more basic than 2. Or I could say 2 is 100 times more acidic than 4. All right, the pH of a human blood is close to 7.4, so we're a little basic. A buffer, though, keeps our blood at a reasonable range. Now, if it did not, we would die, because when the pH drops to 7 or up to 7.8 of your blood, it can kill you. So buffers that you naturally have in your body resist change. That's why you can drink lemonade, which is acidic, and you're still okay. Or you could eat steak, which is basic, and you're still okay because of the buffers in your system. So let me ask you now, the following are pH values of these different things. Which of these liquids has the highest molar concentration of OH, hydroxide? Do you remember that we said more hydrogens is acid and more hydroxides are base? So we're asking you which one is a base. 7 is neutral. To the right is more basic. So the bigger the number, the more basic. And hopefully you came up with a conclusion of human blood. All right. If the pH of a solution is increased from 8 to 9, what does that mean? That's more basic, isn't it? So more OH. So it would be 10 times more OH at 9 than 8. Now, a buffer is a substance that minimizes changes in the concentration of hydrogen and hydroxide ions. So remember, a buffer keeps some solution in a certain range. All right, now how many grams of the molecule in this figure would be required to make a 1 molar solution of a molecule? So how many grams? It's asking you for a weight. So this is 1 molar solution of CHO. How many grams of a molecule in this figure? Okay, so you would have to find the molecular weight of each one. You would need a periodic table. We gave you all of those weights. So you would add up 2 carbons. So carbons you have 2, and the weight on that is 12 grams. So you do 2 times 12 is 24 grams. And then how many oxygens do you have? You have 2, 1, 2. So you're going to add 2 times 16 grams. And then on hydrogens, you have 1, 2, 3, 4. So it would be hydrogens 4 times the weight. And then you would add all of that up together and get a flask, add half the water, 500 mils, add the total of this, and fill it up to the fill line. That's how you make a molar solution as a review. All right, now let's recap. Water makes life possible on Earth. Organisms are made and live and dominated by water. Water exists as a solid, liquid, and a gas, and water has a rare property in a solid state as it floats on the liquid state. So remember 4 different properties of water and how to make a molar solution and the pH scale. See you on the next lesson.